Okay, so this is for developer session. And so I'm going to talk about the programmatic access to the BigQuery. So we have three ways to make programmatic access. The first one is a BQ command line tool. I think you're already familiar with that. And Google's API's client library and REST API. So command line tool, so BQ is a command line tool. So if you use a shell script, it's an easy way. Or most of the language should have a way to call the external process. So process, runtime, I think this is Java. And the third one is C, Ruby, and Perl. I don't know. Right. And the good thing about this is a BQ command line tool will take care of the authentication and authorization. So basically you don't need to worry. If you can run BQ, that's fine. It's already authenticated and stored on your system. The second way is API's client library. This is a common library to access to many of the Google services, including this BigQuery or Computer Engine or Google Calendar. I think we use Google Calendar access for our lab on App Engine. And it supports various languages, not only Java and Python. We support JavaScript, Ruby, PHP. And also we support Google Apps Script also supports this API. And this library takes care of the authentication and authorization with OAuth 2. So what we usually do is we provide client ID and client secret and give that to the library. So third way is REST API. So this is the most raw way to access the API. So here you create HTTP request and optionally request body in JSON format to give more information to the API. And you get HTTP response, and you parse the response. Usually you handle the JSON to get the data. So in this case, credentials must be handled by developer. So you have to manually, acquire the token, refresh token and access token, as Justin explained on Monday or Tuesday. So this is actually a harder way. So if you need a user authentication, you have to show a pop-up window to get users access. So actually, we recommend the second way, API's library. And so here is some common workflow in API's library. So this is a common way to all the services. So first, you get users' credentials. So here we run OAuth flow. Flow is the object. We call it a flow. Flow automatically opens the browser's window if necessary. If you're logged in, it doesn't. And then authorize the HTTP object with the credentials you get from flow. And you create a BigQuery or whatever, Computer Engine or other API object with that authorized HTTP. So let's talk more about the OAuth flow. So in Python, we have this flow class. Or you can create from the flow from client secret function. So that takes, this basically takes a client ID and client secret, and it creates credentials. And similarly, Java has a corresponding class. And it caches a user's credential to the local file. Oh no, I mean, that part is not done automatically. You have to cache the user's credential by yourselves. So in case of the App Engine, Actually, Python has a decorator. Everybody familiar with a Python decorator? Right? Python programmers. So you can set @mark something just in front of your function. So if you set this OAuth2 decorator in front of you, you create OAuth2 decorator with the client ID and secret, and decorate your handler, HTTP handler on App Engine by this decorator. The decorator automatically takes care of authentication and authorization. So if this is first time you access, it redirects to login screen on Google. And after you type username and password, it asks you if it's okay to access to your BigQuery for you. And then from code side, you can get a credential from the decorator. Actually, you can get HTTP, I think. But in Java, actually, Google authorization code flow. So this one is used. And for both languages, real credentials are stored in the data store. So if you use these, and if you go to a data store viewer, you may see some kinds you don't really know, which are used for these credentials. All right, so here is a summary of the programming access. Any questions so far? It's pretty much, the same way or standardized way for Google services. Good? Hungry? Starving? Close to the end. Okay, so this is best use cases for BigQuery. So I talked many times, BigQuery is a very fast analysis engine for huge data. But when we say fast, and you already know it still takes 20, 30 seconds, or maybe a minute for some queries. So when we say fast, it's not really good for real-time response. So dashboard type application or the real-time ingestion is not really a good use case for the BigQuery. This is more for offline analysis. First means first for offline analysis against a huge data, but it's not as fast as milliseconds order. So for these cases, I use a third-party visualization tool, and most of them are equipped with a cache, so they can respond in a faster way. Tableau? Combine? So here is one typical use case of the BigQuery, or the whole view of the data pipeline. So on the left top corner is original data. Original data may come from several servers. It may come from your POS system, or it may come from your sensors. Anyways, it might have many sources, and they might have a different format. So how we do is we first upload everything onto cloud storage, and we do some pre-processing before the data goes into BigQuery. So pre-processing, so we think, so the assumption is this whole data is huge. So we can use App Engine MapReduce or Hadoop on Compute Engine to pre-process the data. Yes. So the question, I think, is we do that. Do you mean our team or as Google? Yes and no. So the question is, say how's the relationship with our Google product. So Google provides this cloud storage or BigQuery or the App Engine, MapReduce, or Hadoop. Or we don't provide Hadoop. We provide Compute Engine. So Google provides these platforms, and it's going to be you who combine these powers into one solution. So, and actually, that is why we do these training sessions. Does it make sense? So, requirements are different per customers, per situations. So we don't really have, set of the nice solutions. Although we do work on some sample applications. For example, our cloud solution team has a sample application that automatically starts up Compute Engine instances and install Hadoop and run MapReduce against cloud storage. So it should be much easier than you go and buy many machines and install Hadoop one by one. So after these pre-processing, so the example of the pre-processing include making the same format from these different logs, or it may do a denormalization is one example. Another example is some data pre-processing that can't be done on BigQuery, such as the IPGeo resolution. So you might have an IP address of the user, but you are not really interested in IP address of the user. You are more interested in geolocation. So you can resolve the IP address into city names or state or country. And after the pre-process is done, the data is ingested into BigQuery, and you can use third-party tool like Tableau, BIM, or WebUI BQ, or API access for further analysis. Cool, this is end of the slide. So here are some references. And exercise time. So Gary, how will we? Before that, does anybody have question? Lunch? Gary, we have a question about the lunch.